Welcome to today's CNCF On Demand webinar, Service Mesh for the Enterprise. I'm Caitlin Barnard, Marketing Manager at CNCF, and today I'm joined by Sean Wormke, Incubation Lead at Aspen Mesh, and Andrew Jenkins, Engineering Lead at Aspen Mesh. The Service Mesh space is quickly maturing, and we've been receiving many questions about them at CNCF now that service meshes like Linkerd and Istio are ready to be used in production deployments. With that in mind, Sean and Andrew are going to answer some of your questions on Service Mesh and how they can be best implemented in the enterprise. And with that, I'm going to hand it over to Sean and Andrew to spend a few minutes on some of the unique things that enterprises need to consider when implementing a service mesh.
Thanks, Caitlin. It's great to be here with you today. Thanks for giving us this opportunity to talk to you about the challenges that enterprises face and how they're using technologies like Kubernetes and Service Mesh to solve them. So we spend a lot of time here at Aspen Mesh talking to some of the world's largest companies about their digital transformation and the things that they're going through on that journey and all the problems that they face along the way. And what we're finding out is that, obviously enterprises need to do more than just scale their applications. They need to monitor, secure, and manage those things at scale, but they need to do it in a way that matches their organizational structure and also complies with their internal and external policies and requirements of their business. They need to do all of this, though, while they're delivering on this promise to their CTO generally that they're going to deploy things faster, while still maintaining their external SLAs for their customers, as well as their internal KPIs that they need to meet. And so what this means for Service Mesh is that in the enterprise, features like MTLS, authentication, RBAC, prioritize policies that let groups configure policies and be able to put them together at runtime, managing clusters across different types of clouds and in different locations, providing observability, and having a supported service mesh or supported technologies in their infrastructure is very important for them to be successful long-term in their transition.
Awesome. Thanks for that overview. So we want to spend the bulk of our time today answering some questions from the community. So we put a call out to the CNCF community for questions to find out what they wanted to know about service meshes in the enterprise. And now we're going to answer some of those questions. So let's kick it off with, why should I use a service mesh?
That's a good question. I think that service mesh sort of provides a couple of primary advantages. So when you have services that talk to each other inside of your infrastructure, everybody has these. You have a lot of them if you have microservices, but no matter what, you have these. You need to develop a couple of communication patterns. So you need some resilience so that you can handle faults in the service-to-service communication. You need security, like Sean was mentioning with MTLS, so that you know things about that you can protect the integrity and confidentiality of the communication between services. And then you also need this inspection layer to be able to understand what's actually happening when it's being successful and effective communication across services, and when it's not, and when you need to debug things. And so it's a really natural fit for microservices where you have a whole lot of these things, and the cost of implementing this resilience and inspection and security layer over and over again is high, but it also even applies even if you're not all the way to microservices yet. It can still provide those same advantages for all your service-to-service communication.
So for companies that are just getting started with this, how can they sell their company on the idea of a service mesh?
Sure, that's a great question. And I think what we see is that generally as teams scale from 1 or 2 small application development teams to much larger enterprise type teams, we see the emergence of this platform team. And that platform team's job is to provide a stable and secure and available platform at which you can run your applications on top of. And this is especially true for enterprises because they oftentimes have dozens or even hundreds of these teams running around, and it becomes very inefficient for everyone to sort of be doing their own thing, right? Creating their own pieces of infrastructure, deciding which tracing libraries they're going to use, for example, and how they implement a lot of these things. And from a company or an executive level, I think one of the most important and main selling points of a service mesh is that they empower teams to really do what they're good at. And what I mean by this is that it allows application developers to really focus on the business value that they're empowered to and required to drive by focusing on solving real business problems and worrying a lot less about the infrastructure. Mm-hmm. And allows these platform teams to really start to focus on how they provide that stable and secure layer of infrastructure underneath those applications, while still providing to other areas of the business the things that they need, like observability, security, uptime. All of those kinds of things come out of it. And all of that then leads into this, faster rate of delivery for applications to the market. But at the same time, it allows for, when there are outages, when there are things like that, a lower mean time to recovery in those situations. So it's really about efficiency. It's really about allowing teams to work on the things that they do best and they know best without having to, and work together without having to step on each other's toes.
Great. So we get a lot of questions about multi-cluster, multi-cloud. Can you talk a little bit about how a service mesh works in these types of situations?
Yeah. So I think there's two ways that I think about, two reasons that you would do something like multi-cluster, multi-cloud. The first is that you want essentially redundancy or disaster kind of recovery or proximity to your client. So this is where you want a bunch of different clusters that are all doing the same thing inside, but they're disparate clusters that are designed to be autonomous so that a fault in one doesn't disrupt another one. So that's one class where you're doing it for sort of fault tolerance. There's another class where what you're doing is you have workloads maybe in different clusters because that's the way your organization is laid out, or some clusters are better suited for certain clouds than for other clouds. And so that's sort of this like workload-specific multi-cluster environment. So in the fault tolerance case, what you want is you do want independence across these things. So you don't necessarily want one overarching service mesh control plane. You want to be careful about what service mesh functionality is actually aware of across these different clusters, because you don't want to create a new single point of failure. And so there's usually a desire as well to have an overarching view of these things all in one single pane of glass. And so organizations have to make choices about how much do they push up to that single pane of glass while maintaining, some independence in the service meshes, the local clusters, so that they have that fault tolerance. For the workload-specific multi-cluster case, what we're seeing is a lot more of you want service mesh to provide an overarching service mesh across clusters, and you want it to simplify that communication. So you definitely want MTLS because you're going to be, you sort of want to create almost like a VPN, but a layer 7 MTLS managed VPN rather than like port forwarding and all that sort of stuff. You want to make a virtual service mesh across all of these different clusters in that case. And so, they're kind of different use cases. They're both things that service mesh, I think, addresses well.
Great. So let's hop in and talk a little bit about how different teams work with service meshes. What's the difference between how the platform team and developers would use a service mesh?
Yeah, so that's a great question. I'll give you a couple of examples maybe from what we've heard from some of our customers. So one of our very first customers came to us with a problem around testing in production, right? So what they had was they had a number of developers, they had a production system, they had a staging system, they had a bunch of test environments around. And what they realized was they were spending a whole lot of money on their test and staging environments, quite a bit more than they were in their production system. And so what they were looking for was a way to eliminate some of those environments and still get sort of the confidence that they needed to roll these things out into production. And so, you know, the application team really didn't care that much about all of the kind of nuances and all the pieces that were in there. They just really wanted to deliver code in a way that was rapid, right? They just said, I just want to write my code. I want to write my fix. It works in my laptop. I just want to push it out and let it go, right? So in that sense, they were focused on delivering that business value, but every time they did that, they said, hey, when this runs in production, it always breaks because the way that you tested it isn't the way that it works in production. And so what we did was we worked with them to use some of Istio's traffic routing rules, some of their observability features and tracing capabilities to develop a feature for them that we call experiments. And what it allowed them to do then is to deploy these experimental and test applications straight from their laptop into production using a canary or blue-green type of approach. And then using the tracing and the observability pieces, we were able to write some analytics on top that helped ensure that both the production, the new fix was no worse and was hopefully better than the one that was running in production. So that's a great example of how sort of service mesh and the technologies there enable both teams to work independently, meet the goals that each one of them have. You know, the goal of releasing rapidly, while as a platform team wanted it for stability. And then also reducing cost. And by doing that, they were able to eliminate a good number of their test environments, not all of them, but a good number of them, and skip their staging deployment altogether.
Very cool. So getting into role-based access control, what RBAC capabilities does a service mesh have?
So I think there's kind of two classes here that I break it down into. So the first one is like end user auth. And so that is the idea that you can actually use a service mesh to authenticate the traffic that the end users are sending in and out and provide and do authorization on the basis of that. And so a good example in Istio, you can use JOT signing, and then you can write rules that decide which end users get to take which actions inside of your service mesh on the basis of matching against roles encoded in that JOT. And so that's an example of a thing that exists. It's not impossible to do without a service mesh. It's just hard and kind of annoying to get right because you have to do it the same way consistently across all your applications. It's a security thing, so it's really important that you get it right. It can be a challenge to coordinate. You know, everybody has to rotate keys. Like it's stuff that is doable, but there are, you know, we're finding a lot of people who want to say, hey, I'd love to have a layer take care of that for me without compromising on security. Service mesh can do that. That's the first part. The second part is RBAC around configuring the service mesh itself. And that's one of these things that I think is going to be really important to enterprises. It's honestly, I think for like service meshes like Istio, it's still kind of maturing and in development. And so this is a lot of thinking about how is it that a large organization with a platform team and these individual development teams, how can they flexibly configure roles in their environment like Kubernetes to say, hey, I want to give this individual developer team this much control over their application. They should totally be allowed to say things like, here's the retry logic for my app. Here are the paths that are idempotent, you could just run again. But we really don't want them to be able to accidentally take over traffic for some other service by misconfiguring something. So we want to be able to use Kubernetes RBAC or some other RBAC system to say, hey, here's the little sandbox that this group gets to play in and inhabit. And Service Mesh kind of addresses both. I think that enterprises are going to do a lot of the driving of that second class of capabilities to say, hey, we've got to make this work with our larger organization structure.
Great. So we've had this next question come up a few times now. So in production environments, especially enterprise production environments, how much overhead does a service mesh add?
Yeah, that's a good question. Most service meshes today are sort of like bumps in the wire. So in order to get the security benefits, things like that, all the packets essentially in and out of the service that you are putting inside the mesh go in and out of the service mesh proxy, like Envoy in the case of Istio. So there is overhead in doing that. There's overhead in latency. I think that most people find that it's it's also hop based. So if you have a very deep sort of graph of microservices, you can pay the penalty for every time you go in and out. And so people are seeing, especially for deep kind of graphs, they're seeing milliseconds, maybe more than 10 milliseconds of latency for some of these things. There's overhead there for sure. I think that there are a lot of people who are addressing this with different tactics. Like now that you have a service mesh and you can understand a lot about what the communication is that's going on, you can do a lot better caching. And I also think that we'll see that data plane behaviors around service mesh will start to improve some of that. I also think that there's a little bit of an argument that the resiliency layer, the retry layers, all these other layers, even if you encode them directly in your application, they're still not free. And overhead is important. It's something that you should evaluate. There are a lot of architectures where the service mesh overhead is totally compatible with the kinds of services that you want to use a service mesh for. And also, all of the service meshes that I'm aware of support gradual adoption. So if there's some part of your network where it's just intractable to have some amount of overhead, you can leave it out of the service mesh until you decide that you really need some capability provided by service mesh.
Awesome. That leads us nicely into our next question about some of the benefits of a service mesh. So how does a service mesh help with development cycles, stuff with improving deployments or operational benefits to the team?
Yeah, so that I'll give one example, and then maybe I'll let Andrew talk a little bit about us using a service mesh here locally and some of the benefits that we've seen from it. One of the challenges I think that you have in these, especially in enterprise environments with lots of teams trying to solve these problems, is that it's really hard for people to get on the same page about what these applications are doing and where problems actually, where the problem actually is, what the root cause of this problem is. When things go bad, right? When there's a production outage. And so one of the things I think that where you really get a lot of efficiencies by using a service mesh is through this observability and tracing feature that comes with it. That combined with some of the traffic routing capabilities and network services that it offers, you get a lot closer view into a single pane of glass, as Andrew was talking about. It's not quite a complete picture, but you get closer to this single view of what's happening, and it helps you really pinpoint where the problem's at and get the right team working on the problem quickly. Because I think, at any time you have an outage in production or you're trying to resolve a problem, it's how fast can you get that thing back up and running and ensure that your customers are being successful with your product. And I think service mesh really, really helps do that through a lot of the observability and tracing features that it offers. And it does it in a way that you can insert those kinds of features into the application stack without having to make a lot of changes to the application itself, right? So what you don't want to have to do is go back to the application development team every single time you need to add a network feature and ask them to change the application, because that's a bunch of inefficiency there. So by having a service mesh, by having that single place in the infrastructure where you can insert some of those services, that drives a lot of the efficiencies that you get out of it. So I don't know, Andrew, if you have anything to share around how we use it here.
Yeah, I mean, I think it's going to be kind of a follow-on in a couple of ways to that. So the first one is we do use that same experiments feature built on top of the service mesh for our own upgrades and deployments. So, hey, we've got a brand new user interface. We want everybody to start playing with it, but we don't necessarily want to flip the switch until we're sure that we've got all the kinks ironed out. So we can hand out tokens that only some people have. and check that they get, that everybody's happy with the new thing, or we can redirect some subset of production traffic. So that does help a lot with final sort of testing for things that are, it's really hard to produce good, really, really high fidelity test environments. And so it's a good judgment, I think, at some point to say, okay, we've done enough, we've done our due diligence of local testing, of integration testing. Now let's use this stuff to get some examples in production with some caveats, with some protections, so that we can just sort of figure that out and get that last little bit of testing in production, where the sort of rubber meets the road. So that's one. Observability is also huge. So here, we move fast. Like the microservices thing is about avoiding a huge upfront design for something, in part until you know how valuable it's going to be. So we will, try new architectures for things and try to keep those low cost. And so that means that we don't spend a lot of time upfront thinking about, okay, how are we going to, get the traces in and out of this service, all that sort of stuff, because we assume there's a service mesh underneath. And so we can go from concept to running on a laptop really quick. That's easy. And then when you say, okay, let's put it kind of in production, or let's put it in some environment where we can throw some more representative traffic at it, being able to get that instrumentation layer for close to free is a huge advantage, because if we decide, yeah, it turns out it's not all that valuable, or we should structure it differently, we haven't invested a whole lot of effort in trying to figure out the right way to do application-specific profiling, things like that. We can just drop it in, take a look, and see. So that accelerates, our development quite a bit. The other one is simply having one way to do all of this, metrics gathering, tracing is a big deal, because everybody's looking at the same data. So we have way fewer conversations about what's actually going on here, because everybody's got the same information everywhere.
That's great. So as companies are either moving to microservices architecture or building that out, are there certain application design choices that they should take into account if they do plan to introduce a service mesh?
I'll say, I think they should try to prefer, especially protocols that are supported by the service mesh they're looking at. So HTTP, HTTP2, gRPC are all very popular and good choices there. Application-specific protocols have some support, but it's limited. And I think you're seeing a lot of things move towards the HTTP sort of, some special layer or API on top of plain old HTTP or HTTP2. So that's the first one. The second one, I think, is, it's general good microservices practice, but trying to keep things that are stateless, sort of all stateless, and then think about where you're going to store your explicit state somewhere else, maybe in a service you manage, maybe in a service that you consume from somebody else. But if you can push all that out, service mesh helps, because you can now, it's really pretty easy to see kind of like that choke point of what were all the state modifications that happened, and that really helps you understand when something went wrong. Maybe I don't understand all the code that went into it all that well, but I can get the ground truth of what actually changed in my state layer. Other things to think about is, if you're thinking about adding resiliency features or something like that to your application, you should think about what a service mesh can provide instead for you. So maybe you don't encode retries into your application, maybe you delegate that to the service mesh. Or maybe you're careful to split up the paths in your application so that you can apply service mesh policy across those things, so that you don't have to worry as much about upgradability or something like that in the future. So, part of it is just when you're thinking about doing something new, asking yourself, how much of it do I have to do? What's the cool business logic that I can write? And then what's the switch that I can flip in my service mesh that'll, do the other half of this work for me?
Awesome. So getting back to the idea of enterprise adoption, do you see enterprises as the main adopters of service meshes?
You want to take that one?
Yeah, sure. Yeah. I think I see enterprises. This is a phase I think where enterprises are going to start really increasing the adoption of service mesh in themselves. And I think that what's going on is that they're trying to move from deployment cycles that for some enterprises are measured in months down to deployment cycles that are we're going to deploy every day, or maybe even every hour, or we're going to break this up into a bunch of microservices, and there will be a deployment going on every 5 minutes or less, right, somewhere in the system. And so the reason that they did that is because they needed to remain competitive. They needed to have a competitive edge around agility, flexibility, a rapid way to make progress. And so they sort of forced on themselves this agility inside of the network and said, okay, fine, we can do this microservices thing where we won't have a great big enterprise service bus. We won't have a 6-month architectural cycle. We'll start to let things be more flexible, and we'll rely on technology to help us adapt to that. But they're sort of choosing to push that on themselves in order to get this competitive edge. So that, I think, means that they are going to adopt this widely. But I also think that there's something in this resiliency, security, communication layer that's just gonna be the way that computers talk to other computers in the near future, right? So think about a network where instead of you choosing to push this kind of flexibility on yourself, it's forced. So one example is something like disaster recovery. So in disaster recovery, right, there's a whole bunch of services. Some of them are available, some of them aren't. Some of them are available until the gas in the generator runs out or until the antenna gets knocked over off the roof. And so they have similar resiliency challenges. They have scaling challenges. This service might be totally overwhelmed because we couldn't plan for how much we were going to need it. If we could plan, it wouldn't be a disaster, right? And so, I think that's another front where, you might see that, hey, this nugget of resiliency, of security, of pushing this down into this layer underneath, you might see the same kind of principles apply there. And I think that kind of applies broadly. So in that sense, it's kind of cool that enterprises and cloud infrastructure are kind of, I guess, leading this for this competitive advantage, but I think it might just be a general principle.
Makes sense. So, for enterprise applications, assuming high traffic, high availability applications, are there certain things that you need to keep in mind when you're scaling up a service mesh for that type of use?
I'm not sure that there's a whole lot that's super specific to service mesh. The service mesh should scale with the application infrastructure. That's part of what it's designed to do. I think that the service mesh implementations are now reaching the point where they're starting to see, real scale. And so we see that this has happened to us as users of service mesh, and as well some of our users here at Aspen Mesh. There have been scalability challenges, but they're less architectural or an aspect of service mesh, and more an aspect of the implementations of the service mesh. And so I think that people who work on service meshes, like us, like the Istio community, like the Linkerd community, we're well positioned, I think, to be able to address some of these things and hopefully provide kind of seamless scalability, or as close as we can get to it as possible underneath your application. The idea is that we should be promising internet style scale without requiring application modification.
Mm-hmm. Awesome. So, all right, that brings us to the end of our questions for today. We covered a lot of ground there. So thank you, Sean and Andrew, for joining me today. And we look forward to seeing everyone at a future CNCF webinar. Have a great day, everyone.
Great.